Hello everyone, today we are continuing our 3D geometry unit with section 2, which is all about surface area. Surface area is the total area of all the faces of a three-dimensional object. Another way to think about that might be how much wrapping paper you would need to cover the object. So if we're looking at these pictures here, the surface area of a prism, you have to find the area of the top of the shape, the bottom of the shape, the front side of the shape, the back side of the shape, the left side of the shape, and the right side of the shape. Once you have the area of each of those sides, you add them together and that's your total surface area. Or thinking back to last week, we talked about nets of shapes. You're essentially finding every area of the net. You're finding the total area of the net. All right, so let's go ahead and look at example number 1, which says find the surface area of the figure below. So in order to find the surface area of a rectangular prism, you first need to recognize the different parts of the figure. So I have let me draw through here the rest of this shape so you can kind of see what I'm working with here. I have, if I were to see the invisible side there, I have 2 rectangular bases, and those are the 3x2 sections. So I have 2 3x2 bases. I have my rectangles that follow the 2 feet tall by 6 feet long height. So I end up with, let's write that as 2 6x2 faces. And I have 2 more faces that cover the 3 foot long by 6 foot long sides. So I end up with 2 6x3 faces. All right, all 3 of these rely on the area of a rectangle formula, which says that area is equal to base times height, or length times width is another way to put it. For each of these shapes, let's go ahead and solve. So let's start with the 2 3x2 bases. I have the base as 3 times the height of 2. 3 times 2 is equal to 6, but there's 2 of them, so I have 2 times 6, which is equal to 12. We'll come back to that number in a little bit. Then I have, for my 2 6x2 faces, I have a base of 6 and a height of 2. 6 times 2 is equal to 12. 2 times 12 is equal to 24. We'll come back to that number. And then I have 2 6x3 faces, where the base would be 6 and the height would be 3. 6 times 3 is equal to 18, and there's 2 of them. 2 times 18 is equal to 36. Now that I have the areas of all of my sides, I'm going to go ahead and add them together to find the total surface area. So surface area is equal to 12 plus 24 plus 36. All right. 24 plus 36 is equal to 60. 60 plus 12 is equal to 72. So my total surface area for this problem, this rectangular prism, is 72 square feet. All right, now let's go ahead and move on to our next example. Example number 2, which says to find the surface area of the figure below. Okay, so the figure below is a triangular prism. Right off the bat, I notice that on my triangular bases, I have the base of 8, but the 2 other sides of the triangle are different than the base. So I am going to have to find the other sides of the triangle on the base in order to solve for this whole thing. So I'm going to go ahead and start with that, and then we'll come back to finding the area of each side. So I have 8 for the base. If I split that in half, then I have two identical triangles. So this distance from one end of the triangle to where the height is listed, that would be 4 because that's half the triangle. So I have 4 squared plus 3 squared, because the height is the same, is equal to the hypotenuse, which is unknown. Let's call that x squared. 4 squared is equal to 16. 3 squared is equal to 9, is equal to x squared still, which means that x squared is equal to 25. I'm going to square root both sides. That tells me that x is equal to 5. So both of these other sides are equal to 5. So now that I have all known sides that I need, I'm recognizing that I have two bases that are the same, so two triangular bases. I have one larger rectangle where it's covering the whole base of the triangle and the height of the prism. So I have one giant rectangle face, and I have two small rectangle faces. Now that I have already found all my sides, solving for the area of each side shouldn't take too much. So let's start with the triangle bases. I have area is equal to 1/2 times base times height. The base of this triangle is 8, so that gives me 1/2 times 8 times the height of the triangle, which is 3. 1/2 of 8 is 4. 4 times 3 is equal to 12. So I have 12 for my area of one triangle, but there's two of them. So I'm going to go ahead and say 2 times 12 is equal to 24, and then we will come back to that number. Now I'm going to go ahead and knock my larger face off. So I have the rectangle formula, area is equal to base times height. The base of my triangle I will call 8, and the height of my triangle is 12. I just switched that around, doesn't really matter. 12 times 8 is equal to 96, and we will come back to that number in a little bit. Now I have the two smaller triangle sides that create the two smaller rectangle faces. So I have area is equal to the base times the height again, where I have 12 for my long side and my height of 5. And 12 times 5 is equal to 60, but there's two of them, so I have 2 times 60, which is equal to 120. And now we're going to go ahead and take those three areas and we're going to add them together. So I have the total surface area is equal to 24 plus 96 plus 120. 24 plus 96 is equal to 120. So I have 120 plus 120. So my total surface area is equal to a grand total of 240 centimeters squared. Example 3 says to find the surface area of the cylinder below. When I'm looking at the cylinder, I'm recognizing that the net of a cylinder gives us a circle on the top of a rectangle connecting to the bottom base, which is also a circle. So I have to find my two bases, and I have one face, or the rectangle that curves around to create our cylinder. In order to find the area of the bases, I need the formula which says, the surface area of the bases. So I have to find the area of a circle. The area of a circle formula gives me that area is equal to pi times r squared. Pi times r squared, we need the radius. This picture gives me the diameter of 16 inches. If the diameter is equal to 16, in order to find the radius, I simply need to divide that in half. 16 divided by 2 is equal to 8, so the radius is equal to 8 inches. So the area of my bases will be pi times 128 squared, which is equal to 64 pi. I'm going to hang on to the pi for a second because I have two bases, so I'm going to multiply 2 times 64 pi, and then we'll multiply the pi in. 2 times 64 is equal to 128, so I have 128 pi. And I'm just going to hang on to that for a second, and you'll see why. We're going to switch over to the face. The face of this cylinder is a rectangle, so the area is base times height. It tells me the height is equal to 10. It gives that to me. Here's the thing that you might not see right away. The length of the rectangle, or what we call base in the formula, has to go all the way around the circle. Stretches all the way around. The distance around the circle is what we call the circumference. So the base of this rectangle is equal to the circumference of the base of the shape. If it helps, let's think of the area for a rectangle as length times width, if that's confusing to you. So I have length times width. So it's the length of my rectangle that is equal to the circumference, rather than calling it the base every time. So before I can find my length, I need to find the circumference of the circle. So the circumference of a circle has a formula, and that formula says C is equal to 2 times pi times r. So I'm going to take that and I'm going to plug that in for my L. So in my formula, I have area is equal to 2 times pi times r times the width. The radius I found to be 8, so I have 2 times pi times 8 times the width, which is 10. When I multiply those all together, I end up with 160 pi. Now that I have my two sections of areas, I'm going to take those and I'm going to find the total surface area by adding them together. So I have 128 pi plus 160 pi. 128 plus 160 is equal to 288 pi. So when I multiply 288 times pi, and I'm again using the pi symbol, that gives me a surface area of about 904.78. We're in surface area, our unit is inches, so I have square inches. On example 4 here, it says to find the surface area of the square-based pyramid below. So when you get to a pyramid, it works the same way where you're finding the area of all of the sides and then you're adding them all together. So the first thing you want to recognize is that this says it's a square-based pyramid. That means that the distance of all sides of the base are 15. So I'm going to go ahead and start with finding the base area. So I have one base where it's a square, so I have area is equal to base times height. Both the base and the height are 15 because it's a square. 15 times 15 is equal to 225, and we'll come back to that number in a little bit. Now I want to find the area of all four sides. Because it's a square base, I have 4 congruent triangular sides. The area for a triangle is equal to 1/2 times base times height. I know that the base of my triangles has to be 15 because the base is a square and they're all 15 for the side length. The height of my triangle is marked to be 12. When I multiply that out, that gives me 90, but I have 4 of them, so I have 4 times the 90, and that gives me 360. Now I want to take my two areas and I want to add them together. So surface area is equal to 225 plus 360. When I add those together, that gives me a grand total of the surface area for 585, not 8, 585 square feet. Now that we've talked about area of a prism and a cylinder, or surface area, I should say, we want to go ahead and find the surface area of a cone, but the cone is a little bit different. Rather than having all bases that you're finding the area of and adding them together, we actually have a formula for the surface area of a cone. The formula says that surface area is equal to pi times r squared plus pi times r times L, where L is the slant height. The slant height, pictured in example 5, is the distance on the outside of the cone from the peak down to the base. It's that line that is L. In this example, they don't give us L, they give us the radius, which is equal to 8, and they give us the height, which is equal to 15, but they don't give us L. So in order to find L, we need to think back to the Pythagorean theorem, where we have a squared plus b squared is equal to c squared, except in this case I have 8 squared. I end up with 8 squared plus 15 squared is equal to L squared. 8 squared is 64, 15 squared is 225, so L squared is equal to a total of 289, and I want to square root both of those things to find L alone. L then is equal to 17 because 17 is equal to the square root of 289. Okay, so now that I have L and I have my height and my radius, I can go ahead and use my formula. So I have surface area is equal to pi times r, which was 8, so 8 squared, plus pi times the radius, which is 8, times L, the slant height, which is 17. So I end up here with 8 squared is 64 pi, plus 8 times 17 is equal to 136 times pi. When I add those together, that gives me 200 pi. 200 times pi gives me a surface area of approximately 628.32 square inches. All right, we have one last type of surface area to talk about, and that's the surface area of a sphere. Like the cone, the surface area of a sphere has a specific formula. So we have the surface area is equal to 4 times pi times r squared. So it's essentially 4 times the area of a circle. So when I look at example 6 here, and I'm trying to find the surface area of a sphere, it gives me a diameter of 24 inches. I again need to find the radius. The radius, you simply divide the diameter by 2. 24 divided by 2 is equal to 12, so I know the radius is equal to 12 inches. Now that I have my radius, I'm going to go ahead and I'm going to plug it into my formula. So I have surface area is equal to 4 times pi times the radius of 12 squared. 12 squared is equal to 144. So I end up with 4 times 144 times pi. 4 times 144 is equal to 576, so I'm left with 576 times pi. When I multiply that out, I get that the surface area is approximately equal to 1,809.56 square inches. Note that even though it's a sphere, the surface area is still square inches. All right, here on example 7, we have Chris just bought his mom a wonderful gift for Christmas. He wants to know how much it would cost to wrap it. If it cost 5 cents per square centimeter of wrapping paper, how much can Chris expect to spend on wrapping the present? Okay, so let's go ahead and look at the surface area of the rectangle first. So I have the surface area of the rectangular prism. The first thing I want to notice is that because it's a rectangular prism, I have 2 bases, and then I have 2 sets of congruent faces. So I have, let's say, 2 9 by 5 faces, and I have 2 9 by 4 faces. All right, let's go ahead and start with finding the area of the bases, and these all have the same rectangular formula, area is equal to base times height. So I have area of my bases, I have 4 and 5, so area is equal to 4 times 5, which is equal to 20, and there's 2 of them. 2 times 20 is equal to 40. We'll come back to that number later. Then I have 2 9 by 5 faces, so I have area is equal to 9 times 5. 9 times 5 is equal to 45, so I have a 40. And, oh, there's actually 2 45s, so let's go ahead and multiply that out. 2 times 45 is equal to 90, so I have a 40 and 90. And now I have 2 9 by 4 faces, so area is equal to 9 times 4. 9 times 4 is equal to 36, and there's 2 of those. 2 times 36 is equal to 72. Now I want to go ahead and add those things together. So I have 90 plus 72 plus 40 is equal to the surface area, which when I add those all together, 90 plus 72 plus 40 is equal to 202. This is all in centimeters and it's surface area, so I have centimeters squared. All right. That's the surface area of the rectangular prism. Now is when things might get a little more complex. We need to find the surface area of the cylinder. Here's the catch. The bottom base of the cylinder is touching the rectangular prism. Because they're connected, you wouldn't put any wrapping paper there. You also wouldn't put any wrapping paper where the area of the cylinder is on the rectangular prism. But we already counted for that area because the area of the rectangular prism, we covered all 4 sides. It's just that this piece of the rectangular prism happens to be elevated. So what we're actually doing when we're finding the surface area of the cylinder, we're only finding the surface area of the cylinder side. Just the side. Surface area of the cylinder side. In order to find the surface area of the cylinder side, or the face, we have to find the circumference of the circle because that is the length of our rectangle. So we're going to go ahead and find circumference, which is equal to 2 times pi times r. It tells me the radius is 2, so that means I'm working with 2 times 2, which is 4, so I have 4 pi. Now I'm going to go ahead and I'm going to take that and I'm going to plug it into my area formula. area of the rectangle is length times width, or base times height, however you want to put it. The height of the rectangle is going to be 3, so my base, 4 pi, times 3 gives me my total area of 12 pi. Now I'm going to go ahead and I'm going to multiply that out. So surface area is about equal to 12 times pi, which is approximately 37.699 centimeters squared. All right. Now that I have the two separate surface areas, I need to add them together to get my total surface area. So my total surface area is equal to 202 plus 37.699. When I add those together, that gives me 239.699. And we are going to go ahead and say that that is approximately 239.7 centimeters squared. We're just going to use that one decimal point on this one. All right. Now that I have my total surface area, I'm going to take that and I'm going to figure out how much the wrapping paper would cost. So the price it gave me was 5 cents per square centimeter. So I have to multiply the cost times the surface area, and that's going to give me an estimated price for the wrapping paper. So I have my cost of 5 cents times the surface area of 239.7, and that is going to equal my estimated price. 239.7 times 0.05 is equal to 11.985. So Chris can expect to pay at minimum $11.99. That's the very minimum, especially because if you've ever bought wrapping paper, it comes in rolls. You can't ever just ask for exactly how much you need, so you're going to be paying more than that, I would expect.
All right, that is where we're going to stop for today. We'll pick back up with section 3 covering volume.